All right, and as promised, we are adding to our toolkit, working with rational numbers. We're adding to that dividing rational numbers. So just like our work with multiplying rational numbers, just like that, follow the same rules that we used for multiplying integers. The same is true for dividing rational numbers. So our goal is to find quotients. That just means the answer to a division problem. Find a quotient for a rational, the quotients of rational numbers. So when we divide two rational numbers, the answer that we get is going to be that quotient. We're going to be able to explain the rules for dividing rational numbers and to use the rules that we know to find the quotients of rational numbers with same signs and also those with different signs. So very, very similar to what we did in the previous lesson. If I see that my signs for my two numbers here, one is negative and one is positive, then my answer is going to be a negative answer. And if I see that my signs are the same here, negative and negative, then my answer is going to be positive. But I'm going to take a moment just to go over the rules for dividing rational numbers in general, regardless of the sign, because you may or may not remember. So if I have 1/2 and I am dividing that by 4/9, so this is just the example given right here, I am going to rewrite that as 1/2 times the inverse of 4/9, which is 9/4. And once I've changed this to a multiplication problem, then I can just multiply the numerators straight across and multiply the denominators straight across. And that is the process that we learned, or reviewed rather, in our last lesson. So we're going to do a little bit of practice with these fractions, but I wanted to make sure we remembered our rules for dividing with fractions. Let's get to it. Before we get to our fraction example, let's go ahead and talk a little bit about our decimal example. Here I have same sign, so I know that my answer is going to be a positive number. But here is a review of multiplying dividing with decimals. And this was something that came up, I think, last week when you were doing a little bit of work with that. So if I have 8 and 4 tenths and I am dividing that by 3 and 6 tenths, I'm going to rewrite this so that the divisor, this number right here that is dividing into my 8 and 4 tenths, I want that to be a whole number. I'm going to do that, or I'm going to be able to do that by just multiplying this number by 10, or whatever power of 10 I need to multiply by to get the decimal to the end of the number and to have a whole number. If I multiply 3 and 6 tenths by 10, that's going to give me a product of 36. So I'm going to rewrite this as 36. Now, if I've done that to my divisor, I'm also going to need to do this to this 8 and 4 tenths. If I multiply 8 and 4 tenths by 10, that's going to give me a product of 84. So now I have, I'm going to write this down a little further. Now I have a division problem. It's a long division problem, and we've been working on this a little bit, that I can begin just to divide out, and I don't have those a pesky decimal there in my divisor. I'm going to ask myself, about how many times do I think 36 could go into 84? Well, you can kind of play around with this a little bit. You can use some estimation, and you could say, well, maybe it goes in twice, right? So you could start with that and say, if it goes in twice, then I would have, so remember, I'm going to divide, and I'm placing the 2 above the 4 because I'm dividing this 36 into that whole 84. I've divided, and then I'm going to multiply. So 2 times 36 is 72. Multiply, and then I'm going to subtract 84 minus 72 is 12. One thing you want to check for, if this number right here were bigger than 36, then I would know that I could divide another 36 into that 84. But since it's a 12 and that's less than the 36, we're okay. So now I have subtracted, and you see I don't have anything to bring down here. I'm actually going to add a decimal and add a 0. And since I added a decimal down in my problem, I'm going to add a decimal to my answer there right above it. So I'm going to bring down this 0. So now I have 36 being divided into about 120. And so you might do a little bit of guess and check, or you just may think of about how many times 36 might go into 120. We're going to try for 3 and just multiply this out. So I'm going to multiply 36 by 3, and that's going to give me 108. And again, I'm going to subtract. So I've got here 12 again. And then I'm going to add a 0 and bring down. And I can see right now that this is going to be a repeating decimal, right? I'm going to keep multiplying and getting the same answer. So I can write this product as 2.3 repeating. And because my signs were the same, my quotient is going to be the same. All right. And then our second problem is a division problem that involves fractions. So for my division problem involving my fractions, I am going to write my first fraction, 6/5, and I'm going to rewrite this as a multiplication problem using the inverse of my second fraction, or the flip of my second fraction. So I've got negative 3/4. To multiply these fractions, I'm going to multiply straight across. So 6 times negative 3 is negative 18. Give myself a little line here. And 5 times 4 is 20. I will ask you, super friends, to make sure that you're always writing your fractions in simplest terms. So I know that I can divide both 18 and 20 by 2. So if I divide 18 by 2, it's going to give me 9, and 20 divided by 2 is 10. So my answer here is a negative because my signs were different. Awesome sauce. It is time for you to do some practice on your own, and then you will move on to your self-assessment and then ultimately your practice. All right. I am going to show you try it out here in the next slide. All right, and you may move on to your practice after your self-assessment.